All right, so this video is accompanying the Lesson 7 PowerPoint tides with the title chart portion attached to the end. I was trying to find a way to record and have the video in the back. I don't know much about video editing, so I'm not going to figure that out personally. I will get that set up for the second semester because that's probably really useful, but that's something that we don't have right now. So instead, you can have this video playing, you can have the PowerPoint up, and you'll see me and hear me click through the PowerPoint when I'm talking about a new slide. So this is kind of like have this video playing in the background, go through the PowerPoint. Those explanations will match up 1-to-1. But for tides, we already kind of laid some basic groundwork for tides, even though our discussions have been very brief, very thorough, or not very thorough, and just kind of flying through. The basics are there. You kind of already had these basics as well, where tides are these rising and falling of ocean water along coastlines, depending on the gravitational pull of the sun and the moon, working either together or working against one another. So, a tide, as a pure definition, is a periodic change in water level that occurs along coastlines. Again, we have two key words here. We have periodic and we have coastlines. Periodic means that it occurs again and again in a repeating pattern or a cycle. Coastlines are the only places that we see tides. We do not see or find tides out in the open ocean because we have no reference point. It's true that your water may be moving up and down, but it doesn't mean anything. Your water may be creating bigger waves or such, but the relative water level isn't going to increase or decrease as a result. Now, you have the sun and the moon working together. Each has a gravitational pull. Obviously, the sun is much, much larger than the moon, but the moon is closer, so its gravitational effect is much stronger than the sun's, so it has a little bit more sway or leeway than the sun. Kind of just answered my own question. Sorry, I'm ahead of myself. Just that smart. Now, forget the sea moon joke. If you don't get it, you don't get it. It ties into the song that's playing in the PowerPoint at the start if you download it and play it, but can't really break that one down if you don't know it. Anyway, like we've discussed, we have 4 major phases of the moon to go over. Those 4 phases are kind of one of 4 positions around the globe. This is not literally how they are represented in the real world, but instead we have these 4 positions just being representations on a flat 2D diagram. So, over on the left, that big, bright, orange-yellow orb is the sun, as always. I think that's easy enough to pick out. And that dotted line from the sun to the earth is a representation of the gravitational pull of the sun to the earth. If there was no gravitational pull between the sun and the earth would just go flying. It wouldn't have an orbit, but it does have an orbit. It does revolve around the sun. Over in position 1, this black sphere, this is our new moon. The reason that it's represented as a black sphere is simply because your new moon in the night sky literally looks like a black sphere. You can't really see it against the night sky most of the time. Unless you have a very bright night sky, you're not going to notice a new moon. Then, about a week or so later, we end up at the... I'm not going in that order. Never mind. So, we have new moon at the position between the sun and the earth. And then when the moon is on the other side and being illuminated by the sun, that's our full moon. Now, your lunar cycle roughly, and I do mean roughly, follows the length of a month in a calendar. It's about every 4 weeks or so that cycle repeats. So about 2 weeks after your new moon, you'll see a full moon. Could be less than 2 weeks, could be a little more, but it's not going to be a drastic where you have to see your new moon and full moon happen within a month's time. Now, position 2, we have our first quarter moon. I know it's tempting to call it a half moon, and that's not technically wrong. It is a half moon. That is the way that we've learned it since we were young. But first quarter and third quarter, or last quarter moon, those are the terms that we are going to use moving forward just to keep some consistency in here. You can look at them and say that they are half moons, but quarter moons is just the term that we're going to use. What I want you to notice is from your new moon, it starts with a black sphere. If that black portion was rotating, you're seeing that light portion start to rotate from the right to the front. It disappears again and it turns black as it follows your new moon, first quarter, full moon, third quarter cycle. That whole idea of the moon being dark at the new moon phase, slowly becoming lighter until it becomes a full moon, and then becoming dark again as it enters your third quarter and finally the new moon again. This is that repetitive cycle that makes these symbols be a little bit more logical and not just something arbitrary. Now, with your phases of the moon, you end up with two special kinds of tides called spring and neap tides. A spring tide is where we see the Earth experiencing the highest high tides and lowest low tides. You have the strongest gravitational effect of the sun and the moon on Earth's oceans, and so you see extreme ends of tidal changes, where you're gonna have your high highs and you're gonna have your low lows. To be clear, this is not the perfect where on the day of the full moon and the new moon, you will always see your highest highs and lowest lows. Sometimes it's a little bit before, sometimes it's a little bit after. It's just a matter of if the conditions are right with the moon. That's the moon. It's far away. It does what it wants. Opposite to our spring tide are our neap tides. Neap tide, N-E-A-P, is when the Earth experiences the smallest change between high and low tide. So, to draw this out and just show this to you, your spring tide would look something like this on a tidal chart. Where you have extreme highs and extreme lows, but your neap tide is going to look something like this. So your neap tide now has these really low peaks and low and high valleys, but there's not much change between your high and low tide. So instead of these dramatic shifts where you have a really high tide and the water comes really far up, it would rise a little bit, it'd fall a little bit, rise a little bit, fall a little bit, and then eventually that'll stretch out to form the spring tide and then shrink to form a neap tide. This is a repeating cycle. It's part of that periodicness or periodic ability of your tides changing. So, just to reiterate, for our spring tide on that tidal chart that we see on the notes, positions 1 and 3, the ones that are horizontal between the sun or with the sun and Earth, those are positions 1 and 3. Those are the new moon and full moon. This is where we see a spring tide. And then a neap tide is going to occur at positions 2 and 4, your first and third quarter moon. Now, just to visualize what that looks like, you can play this on your computer, but all it is the sun, the Earth exist here, and between it, you either have the moon in between the sun and the Earth, or you have the moon on the opposite side, but they're horizontal, and they pull. Oh, that's my chicken nuggets. But your moon is pulling on the Earth's oceans, and you also have the sun pulling on the Earth's oceans. So you have what's known as a solar tide and a lunar tide. Those move in the same way. So when those tides move in conjunction, you have a much greater change in your tidal waves across the course of a day. For neap tides, instead of having your sun and moon work together and pull on the Earth's oceans, you have them working against each other, where the sun is pulling in this direction and the moon is pulling in this direction. Those cancel out, and now you have sort of just a all-around average tide. Now, we have a couple other terms that tie into our tide types. The first of which is a diurnal tide. Diurnal is the condition or the way of having one high tide and one low tide every 24 hours. So over the course of a full 24-hour day, you would only see one low tide and you would see one high tide. You don't have any more or any less. It's simply one high, one low. This is a much rarer case, especially where we are. This part of Florida doesn't see very many diurnal tides, or at least not regular diurnal tides. But coastal areas as a whole just sort of see these sparsely. Now, looking at the depiction of a diurnal tide, low tide is that valley over on the left. On this one at about 6 hours, and your high tide is over at around 18 hours. So it's not always perfect, but there's supposed to be about a 12-hour difference between those low and high tides. Depending on how high or how low your tide is, your shift or your slope, your increase in water level or decrease in water level can be very extreme and very, very fast. It's a little rarer, but it can happen. We then have semi-diurnal tides. This is where we now have 2 highs and 2 lows every 24 hours. Semi-diurnal tides are a little bit ideal, the same way that diurnal tides are. And this is the most common type of tide for our coastal areas. Having this 6-hour shift, roughly 6-hour shift between your tide types, most coastal areas see something to this effect. Looking at the representation of your semi-diurnal tide, you have your low tides at about 6 hours and 18 hours, so there is a 12-hour difference between your low tides. But the next true tidal shift is from 6 hours to 12 hours, where you have your high tide at 12 hours and a high tide at 24 hours. Now, the way it looks on this graph, it may look like there's 5 tides total. And if this tide or this tidal chart were perfect, the actual tide on the left would be right before midnight. However, these are never perfect. These will never ever be perfect whatsoever. You're going to have some kind of, it's not 6 hours, it's actually 5. It's not 6 hours, it's 7.5, 8 hours. And you can go a much longer stretch of time without seeing a true high or low tide. Now, after semi-diurnal tides, we have mixed semi-diurnal tides. Mixed semi-diurnal tides are similar to these semi-diurnal tides that give them their name, where you have 2 highs and 2 lows. But now, you have those highs and lows being at different levels. So your second high tide will not be necessarily the same height that your last one was. It can be higher, it can be lower. The same goes for your low tides. Your second low tide will be at a different low, either much lower or much higher than that previous low tide. These are going to be what fill in the gap between your major moon phases. So let's say as you move from new moon to first quarter moon, the rest of that roughly week-long period is going to be made of your mixed semi-diurnal tides. So if you're looking at your mixed semi-diurnal tide charts, and you're looking at it for everything from new moon to first quarter moon, they'll all look like some random scramble of highs and low tides. Looking at the example that I've given you here, you see your low tides. The first one is a lot lower, your second one is a lot higher, but your high tides are roughly at the same level. It doesn't have to be where both the high and low tides are going to be at different heights, but as long as one is different, that's enough to show you this mixed semi-diurnal tide pattern. Now, a couple other tide terms to hold on to. First is your ebb tide. We talked about ebb tides on our preview assignment, but any falling tide, anywhere where the water is getting lower or receding, that is an ebb tide. Opposite to an ebb tide is the flood tide. If you've heard the phrase ebb and flow, the rise and fall of life, the ups and downs of life, ebb and flow is exactly like ebb and flood. Flood and flow have similar roots. They just mean the same thing in the context of that saying. But ebb tides are any falling tide. A flood tide is any rising tide. And then we have this concept known as slack water that exists between your ebb and flood tides. This is where your tidal currents are going to slow down, and then they'll turn around and they'll change direction between your high and low tide. So for it to be a high tide or to become a high tide, your water level has to come in and the water level has to increase. In order for that to happen after a low tide, that water level has to stop receding and start coming in shore. That process of just turning around where there's no direction for a little bit, that's slack water. So looking at that tidal chart that I've given you, this is a diurnal tide chart. You have this falling tide or ebb tide on the left, heading toward your low tide. You then have a rise afterwards. This is your flood tide. So your ebb tide and flood tide kind of bookend your low tide here. Oh, and the slack water did not show up on here. Okay, that's annoying. Cool, love that. If you're looking at this tidal chart, so you have your low tide around 6 hours, your slack water is going to be right next to that 6 hour mark. Shaking that. It's going to be right next to your 6 hour mark where after the ebb tide, the water is falling, it's receding. It's going to start receding slower right after your low tide. You now have the ability to say, wait, the water needs to start increasing. The water needs to start coming inshore. So right around your low tide, you're going to be dealing with this current, this tidal current stopping, reversing direction, and start to increase in level. So right around your low tide point, that is going to be your slack water. I wish I'd put this on here, and I'm upset that I didn't, but I can represent this for us better next week. We won't really be talking about slack water until next week anyway, so that's okay. Now, we talked about this next portion in class together on Tuesday, but just to review for all of you, we have our 4 major moon phases on tide charts, being new moon, first quarter moon, full moon, and third quarter moon. These 4 symbols that you're seeing on the PowerPoint, those are the symbols that you're going to see on tide charts, any and all tide charts. These are the simplified versions of your moon phases. That's just the way to read them. Now, looking at your tide chart, you have a couple pieces to note here. First, we have our big black letters. Those are the days, big black numbers, sorry. Those are the days of the month. Pretty self-explanatory. You've all seen a calendar before. And beneath that day of the month is your day of the week, Monday through Sunday. Very self-explanatory. But then we have this first box right here with times. These are the predicted time of the tide. We can predict when our high and low tides are going to occur. So, looking at this, the 3rd of March, we have our first tide at 1:46 a.m. We then have another tide at 7:07, 12:33, and 8:16. These are not perfect 6-hour intervals. They're a little bit less or a little bit more than 6 hours. That's just the reality of how tides end up working. But next to our time column, we have our height column. The one that's boxed is in feet. You can ignore centimeters. We will not be using centimeters for the purposes of this class. But those heights, those are the heights of the tides themselves. These are the predicted height of it. This is the predicted height of a tide relative to sea level. That idea of being relative to sea level is important only because it gives us a clear baseline from which to judge everything else. What I want you to notice, if you heard me talk about this on Tuesday, you can skip and you don't need to hear this, but if you're looking at your tidal chart and you're seeing, all right, let's look at the 4th of March. We start with a tide at 3:15 a.m. That's 1.2 feet above sea level. But it doesn't tell you if that's a high tide or a low tide. You have no idea on its own. But if you look at the next tide at 7:26 a.m., you have your tide height at 1.0 feet above sea level. We went from 1.2 feet down to 1.0, and then at 12:58 p.m., we go up to 1.9. So if we're going down and then up between the first, second, and third tidal tides, we have to start at a high tide at 1.2, drop to a low tide at 1.0, and then increase again to a high tide at 1.9 feet. That pattern of seeing decreases and increases, this is how you read your tidal chart and know if you're dealing with a high tide or a low tide. Once we start working with our graphs, like you saw in the notes, once we start working with those, this will be an easier way to represent it. But reading the numbers, understanding that the numbers by themselves can give you that information and you don't need to visually represent this, that is more than enough for the time being. Then lastly, at the bottom left, we have those small symbols for our important moon phases. If you're looking at this entire tidal chart, all this information may seem pretty daunting because there are so many numbers, but just being able to read these and pick up these small bits of information that you're being asked for, that's what we're going for here. So that's the end of this. I just want to wish you luck. If you have any questions, please message me on Remind. I understand this is a little bit thrown together, but again, it's not so bad. Now, if you're listening to this video in class, I probably should have said this at the beginning. Hopefully you're not playing this out loud because that's a lot of my voice playing and that's disturbing. So if you need headphones, remember there are always the headphones in the front bin, in the cart. Just please make sure you put them back if you use them. If you need your mouse to make the assignment easier, those mice are always there for you as well. If you have any questions, please let me know. Otherwise, I wish you guys the best of luck, and I will see you all on Monday. Bye, guys.